Hi, this is Ken Stafford. I am going to be going through the June 2023 Foundation Paper 2 from Edexcel. As I go through, there's going to be automated captions at the bottom of the video. I'm not writing these, so if there's any weird spellings, please don't feel like that's me that can't spell. They're generally pretty accurate. And as we go through this, what you'll see is some things that have been highlighted, some clues put on this because I produced some hint papers, which are the exam papers with a few hints in certain places and the key information highlighted. It helps me to do these videos, but also you might find those papers useful, so I'll put a link in the description. Anyway, let's get into question 1. So we're writing 6,184 to the nearest 100, and the 1 is the 100. And it's the number after the 1, it's the 8 that's going to decide. We go up from 6,100 to 6,200 because the 8 rounds us up. 0.7 as a fraction. Well, 0.7 as a decimal is a fraction. The 7 is in the tenths column. And how many tenths have we got? Well, we got 7. That's what 0.7 means. It means 7 tenths. All decimals are fractions. They're just out of 10, 100, or 1,000, and so on. Question 3, change 9 meters into centimeters. Well, to do this, we need to know that 1 meter is 100 centimeters. So 9 meters is 9 times as long, so 900 centimeters. And to simplify this, we're going to do 3 times 4, which is 12. 3 times 40 is 12t. Question 5, we've got a list of numbers here and we're asked to identify which one is a multiple of 25. So multiples of 25 are 25, 50, 75, 100. So it's like the 25 times table, not to be confused with factors. And as we can see, 100 is there. So 100 is our answer. Would have been actually a trickier question if they'd put 5 here, say, because we might have been tempted to pick that because 5 is a factor. When you're doing these papers, you want to be aiming to get full marks as far as you can. How far through the paper can you get without making a mistake or barely making any mistakes? So if you're struggling at the start, this is a good place to practice. Just practice on the start, the front of different papers. And I actually got some on my website, which are all the front 2 pages of each paper put together into worksheets. I can put a link to that in the description as well. So probability in question 6. I just need to mark the probability across that Shari gets the number 7 on a dice. Well, that's not possible because a dice goes up to 6. So we mark here to show that it's impossible. Part B, on the probability scale, mark a cross with the probability that Shari gets an even number. So you are expected to know about a dice. There are 6 numbers on the dice, and half of them are even. Quickly sketch what they look like. So 3 out of the 6 are even, so that's half of them. So we put a cross in the middle. Now your answers to question 7 might depend on how your paper you've done is printed, and you might even be looking at it on the screen, so you might not even be able to do this. But the length of AC, and I've highlighted it in red, is 9.3 centimeters. And in the actual exam, they were willing to accept 9.1 to 9.5 as an answer. And angle B, if you're unsure how to measure angles, then you should ask your maths teacher or maybe have a look for some videos on how to use a protractor. But we should be getting 96 degrees for this. And again, there would be a range. I say 96 degrees, 106 degrees, I mean. So that angle is 106 degrees. And they accepted any angle from 104 to 108. Okay. And then here is a different triangle. And we're told that key QP is equal to QR, and I've highlighted those. What we also do is this hatching, which indicates they're the same length. And what type of mathematical name for the triangle is this? Well, this is an isosceles. Isosceles have two sides of equal lengths. And that's an easy mark, or impossible if you don't know it. Again, this is a map has a scale of 1 centimetre, 4 kilometres. Okay, we don't need to measure this because we're told the lengths. And we're asked to work out the real distance from P to R. Well, that's 8 plus 16 on the map, which is 24. Use your calculator for that, even though it's easy. As you've got it, you might as well use it. And if 1 centimetre equals 4 kilometres, 24 centimetres must be 24 times longer. So we're going to do 4 times 24, which is 96 kilometres. Okay. Put your answer down on the number line. Although if this is your real exam, the examiner will look for your answer, but why make them look? Just put it on the answer line. And we're being asked what the next term of this sequence is for question 9. So we should always be looking, what's the sequence going up in? So we're adding on 5 each time. And actually, when a sequence goes up in 5s, it alternates between the two numbers it ends in. This is alternating between ending in 8 and ending in 3. So the next one will end in 8, it's 28, because 23 add 5 is 28. And then write down the ratio of the second term to the fourth term. So again, I've used highlighters to try and make this a bit clearer. So the second term is 8, and the fourth term is 18. To simplify this, we're looking for numbers that go into both. Well, straight away I can see that we can halve it. 4 to 9. Can we go any further? No, there's no more common factors. You can also use your calculator to do this by typing it in as 8 out of 18 and then pushing equals. It will say 4/9, which isn't what the ratio means, but you can use your calculator to simplify ratios. Question 10. We've got a graph that shows the cost of parking in a car park for up to 12 hours. And the first question is, find the cost of parking a car for 4 hours. So again, I've got this highlighted, come up from 4 hours, and that is telling me it's going to be £6. And then I think part B, let's zoom out a little bit. When he drives out of his car park, he has to pay £9. So we can figure out from the cost how long he's been there. So 6 hours. So he was in the car park for 6 hours and he arrived at 8 in the morning. So if we add on 6 hours to 8, we get 1400. So we can put it as 1400 hours or 2 p.m, whichever you prefer. I'm sure it'll accept both. Let's quickly check the mark scheme. It did want it as 24 hours, but it did accept 2 p.m. as well. And again, this is the hint paper. So if you were doing this question using my hint paper, it's giving you a bit of a clue of what to do here. I've kind of written down what we should do first. We've got the weights of people in a hotel lift. So there is one person who weighs 40 kilograms. So their weight, the overall weight of that one person is 40 kilograms. 2 people weigh 50 kilograms. So that's 100 kilograms. 4 people weigh 60 kilograms. So the total weight of those 4 people is 4 times 60. 240, and we keep going as we go down. We times the number of people by the weight, and again, use your calculator. Even if these feel like the easiest sums in the world, why not just use your calculator? And last of all, 90 times 1 is 90, and then we want the total weight. So that will be the weights of everyone in the lift. So we're going to add all these up, and we should get a total weight of 1060. So, show that the weight of the people in the lift is less than 1,200 kilograms. Well, we have done, haven't we? Question 12, we're told that shape A has been reflected in a mirror line to give shape B. And we've got to draw the mirror line. So we should be aware that this has been reflected diagonally just by looking at it. And the mirror line is going to go exactly in between these points, which would be here for that. So if I draw it on, this is going to be our mirror line. Okay. In question 13, we're told there are 50 teachers in the school, and that is 1/16 of the total number of people in the school. There are more than 50 people in the school. So to get to the whole school, what do we times 1/16 by? Well, the reciprocal of 1/16, which is 16. So we're going to do 50 times 16 to figure out how many people are in the school in total. Use your calculator, but 50 times 16 is 800. The other thing we could have done is we could have done 50 divided by 1/16. That would also have worked, but 800 is our answer. Question 14, we've got packets of sweets that are being put into boxes. Now, straight off, the packets dimensions are given in millimeters and the box's dimensions are given in centimeters. And we need to be working in the same measurements, either both in millimeters or both in centimeters. I've decided to convert the millimeters to centimeters, and we do that by dividing by 10 because there are 10 millimeters in each centimeter. So these are the dimensions of the packets when they're converted to centimeters. Now we've got to figure out how many packets can go into each box. We've got a few ways of doing this. Now we could work out the volume of the small box, which would be 8. Let's do it with one color. 8 times 6 times 2, which will be 96. And we could work out the volume of the big box. So 72 times 48 times 24. Definitely using my calculator for that. And that volume is 82,944. So we could now figure out, well, how many packets of sweets fit into the boxes by doing a division of 82,000. Let's rewrite that because it's a bit messy. 82,944 divided by 96. I do like to write my divisions like that. And we get 864 packets. Now, the way I prefer is actually just to think about fitting them inside. If the packet is 8 centimeters long, I think, well, how many 8s can I get along here? How many 8s in 72? So I can fit 9 along here. How many 6s in 48? Well, 6 goes into 48 8 times. And then how many 2s in 24? Well, that's 12. And actually, if we now do 9 times 8 times 12, we should get 864. Yeah. So either way, we get 864. What I prefer about the second method is if this was actually 25 centimeters high, we couldn't have got any more packets in. But using the first method, we might have felt like we could because the overall volume of the box would have been bigger, but they actually wouldn't have fit inside. So I prefer the second way of doing it, where you look at fitting them inside. Lots of questions like that on my website. If I whiz through that a bit quickly and you'd like to do another one, just follow links to my website. And here we've got an ordinary dice and a fair 8-sided spinner. This is question 15. Charlie throws the dice once and spins the spinner once. Is Charlie more likely to get a number less than 3 on the dice or a number greater than 5 on the spinner? Well, numbers less than 3 on the dice are 1 and 2. Now we don't include 3 because 3 is not less than 3. Only 1 and 2 are less than 3. and then greater than 5 on the spinner. So again, we're not going to include 5 because we want numbers that are greater. So on the dice, 2 out of 6 are less than 3, and on the spinner, 3 out of 8, we get greater than 5. So now we've got to compare which of these is bigger. Okay, so is 2 6 bigger or 3 8 bigger? Well, what we can do is put them in the calculator and convert them to a decimal. So 2 6, which simplified to a third, as a decimal is 0.3 recurring. 3 8, when we convert that to a decimal, we get 0.375. And 0.375 is bigger than 0.3 recurring. So 3 8 is bigger than 1/3 or 2 6. So it's the spinner that we're more likely to get this on. So we're going to indicate it's the spinner. Question 16. We've got Paolo driving at 56 kilometers per hour for 1 hour 45 minutes. Now, what 56 kilometers per hour means is that in 1 hour, he will drive 56 kilometers. And the reason that can help us is if we think about it as half an hour then, so 30 minutes, that would be half of 56, so half the distance, so 28 kilometers. If we halve it again, we know how far he'll drive in 15 minutes. He would drive 14 kilometers. The reason I'm doing this is that 30 plus 15 gives us our 45. So in 45 minutes, Paolo would drive whatever 28 add 14 is. It's 42 kilometers. So overall, how far will he drive in 1 hour and 45 minutes? Well, we're going to add together how far he drives in an hour with how far he drives in 45 minutes. So we're going to do 56 add 42. And that is 98 kilometers. Question 17, we're told there are 3 cinemas and that the mean number of seats per cinema is 380. That must mean that if you divide the total by 3, you get 380. So to figure out the total, we do 380 times 3. And 380 times 3 gives us total number of seats in all 3 cinemas of 1,140. Now we know how many seats are in Cinema A and Cinema B. There's 350 in Cinema A, and there's 250 in Cinema B. So that is 600 seats we know about in Cinema A and B. So if we take those 600 seats away from the total, we will figure out how many seats are in Cinema C. And that is 540. Question 18. Asher buys 180 cans of cola, and the cans are sold in packs, and there are 12 cans in each pack. Each pack costs £3. So straight off, we can figure out how many packs Asher had to buy. That would be figured out by dividing 180, the total amount of cans, by how many cans are in each pack. And 180 divided by 12, 15. So she bought 15 packs, and each pack costs £3. So the total cost is going to be 15 times 3, which is 45. So Asher spends £45 buying this Coke. Part B is separate. It's not got to do with Asher. Ethan buys a box of 24 cans of lemonade for £7, and there are 330 millilitres of lemonade in each can. So how much lemonade is in the 24 cans? Well, if we do 24 times 330, we will figure out the total amount of lemonade he's bought, which is 7,920 millilitres. And that 7,920, I'm writing it wrong, 7,920 millilitres cost £7. and it wants to know the cost of 100 millilitres. So let's just zoom in on this. We can ignore everything else. We just need to figure out what we divide 7,920 by to get 100, and we'll do the same to £7. Now, the way we can figure that out is if we divide 7,920 by 100, and we get 79.2, that must be what you divide 7,920 by to get 100. And then we can divide £7 by 79.2. Now, you might want to type it in as 700 pence. Go straight into pence because we're going to end up in pence here, aren't we? And I get 8.83 recurring. I'll put that in a different colour. 8.83, and these are pennies. The 8 recurs and the 3 recurs. And it wants the answer to the nearest penny, so we round to the nearest whole number. It rounds up to 9 because of the 8 after the 8 is closer, is 5 or above, so we go up to 9p. So it's 9p per 100 millilitres. Question 19, we've got a frequency tree. These are quite learnable. If you do enough of these, you'll get the hang of them. Again, I've sort of gone ahead and highlighted here. So straight off, we're told 150 people have a car of the 250. That means we know straight away how many don't have a car. We can do 240, take away 150, and that tells us that 90 people don't have a car. Okay, 110 have a bicycle. Now, the issue with using this right now is these two, I was going to say circles, they're not circles, they're ellipses. These two add up to 110, and we don't know either of them yet. So we're going to skip the middle bit, and they quite like to do this in the exam. Sometimes you've got to go to the next bit of information, then come back. We're told 65 of the people who have a bicycle do not have a car. So that means we're going to put 65 in here. And that then means we can do 90 take away 65 to figure out how many people do not have a bicycle and do not have a car. That is 25 people. And then we can come up to this green bit I've highlighted here. If 110 have a bike, this is 110 take away 65, which is 45. And now if we take that 45 off of 150, we get the final part. The way these work, I probably should have said that at the start. This 150, these two split to make 150. If they don't add up to 150, you've gone wrong. What percentage of the 150 people who have a car also have a bicycle? Now, we're talking about people who have a car and also have a bicycle. So we're talking about those 45 people. Now, if you're asked to convert it to a percentage, it's 45 out of the 150. It's not out of the 240. If we type that into our calculator and push equals, it simplifies it to 3/10. So you might at that point know what it is as a percentage. If we convert it to a decimal, it's 0.3. And to get it to a percentage, we times by 100. So it's 30% of the 150 people who have a car also have a bicycle. Okay, question 20 here. We should just be able to put this straight in on our calculator. If you get it right, you will get both marks. And as long as it looks like it does on the question sheet on your calculator, you should be getting the marks. And I am getting, and it says all the figures on your display. Just do whatever shows up on the screen. It only really wants 3 or 4 decimal places, but let's just put it in what we got there. And then work out the value of the reciprocal of 0.625. So reciprocals are written like this. So the reciprocal of 2 is a half. And you might have done this in class where you flip a number over. We use it when we're dividing fractions. That's what gives you the reciprocal. So to get the reciprocal of 0.625, we're just going to type it into the calculator to the power of -1. And the calculator will tell you it's 8/5, which is 1.6. I'm just deleting this because I'm going to upload these solutions. So if you ever just want to look at the solutions and not the video, it's quite a nice way of working. And you should look at the video if the solutions don't really make sense to you. Product of prime factors, this is a really learnable topic. We should be happy to see this. It's the factor tree. Now I'm going to do this without the calculator, but the calculator will do this for you. Let's do it without. Let's talk about what I've done here. I split 60 up into 2 times 30, and I circled the 2 because it's prime. It can't be broken up into another 2 numbers at times to make it, other than 1 and 2. And then when we got to 30, I always go with 2 until I can't anymore. When I got to 15, 2 didn't go anymore, but 3 times 5 makes 15. Now to write this at the end, we do 2, or I'm in my highlighter, let's come out of that. 2 times 2 times 3 times 5. That is it written as a product of prime factors. If you put commas between them, which I've seen when marking these, if you put addition symbols between them, you lose the second mark. It's got to be a time symbol between it. The perfect answer, we write it as 2 squared times 3 to the 5. It doesn't really matter in terms of getting the marks. And actually, you can just do this on the calculator. Depending on your calculator, if you type in 60, if you've got one of the newer ones, we can just format it as a product of prime factors. If you've got one of the older ones, you have to push shift and fact. Once you pushed in 60 and pushed equal, there's a couple of ways of doing this. So you can do it on your calculator. It's worth learning how to do it because if this comes up, it's 2 easy marks. Question 22, about counters in the bag. There are only red counters and blue counters. And we're told the number of red counters, number of blue counters is 1 to 2. And then Helen said something and we've got to figure out if she's correct. She has to work out how many red counters in the bag. She says 24 red counters in the bag because 1 is half of 2 and 24 is half of 48. Kind of doesn't make much sense to me. So a good way of doing these is what we could do is just ignore it and do the question like share 48 in a 1 to 2 ratio. To do that, we divide 48 by 3. We add the parts together. 48 divided by 3 is 16. So there are 16 red. And we times that by 2 to get the blue counters. 16 times 2 is 32. So there are 32 blue. It's sometimes quite hard to explain what they've done wrong. So we can just say, no, she is incorrect, and say what the answer should be. There should be 16 red. Okay, question 23. We're getting towards the end of the paper here. N is an integer. That just is the stupid maths name for whole number. And N is between -2 and 5. And what's the greatest possible value of N? Well, it can be, because it's an integer, it can be -2, it can be -1. We include 0, 1, 2, 3, 4, 5. But because this inequality symbol is less than, it doesn't include 5. So our answer is 4. 4 is the greatest possible value of N if it's a whole number. On this number line, we're going to draw this inequality. So what you do is you put a circle above the 2 numbers it involves. If it's between 2 values, connect them up. And then we look at the symbols. This symbol means that M can be 4, so we colour it in. The other one, it can't be 1, it's less than 1, so we don't colour it in. Really nice question to practice that. There's lots of nice worksheets on that. Part C, we've got to solve this inequality. It's not the nicest inequality. I would always think about dealing with the minus 4 first to get rid of it. To get rid of minus 4, you have to add 4. 6 add 4 is 10. Now we want to get rid of that 2/5. Well, we can times by the reciprocal. That would always get rid of it. So we could times by 5/2. Or we could divide by 5 and times by 2. But actually, I like timesing by the reciprocal here. We're effectively timesing by 2.5. That's what 5/2 is. 10 times 5/2 is 25. Important to note here, if you just put 25 on the answer line, you don't get the full marks. We're after G being less than 25. So we've got to put the letter and the inequality symbol when we're solving inequalities. So G is less than 25. Question 24, we've got a triangle and a rectangle, and it's about area. So algebraically, the area of the triangle, we would do 8 times 6x. So base times height, and we've got to remember to divide by 2. So 48x divided by 2 is 24x. So that is an expression for the area. We don't know what x is, but whatever it is, you times it by 24 to get the area of the triangle. To do the area of the rectangle, we're going to do 5 multiplied by 4x minus 1. We're doing length times width. That's how we get an area of a rectangle. And this is where brackets comes from, because we've got to times all of 4x minus 1 by 5. 5 times 4 is 20. 5 times 4x is 20x. 5 times 1 is 5. And we put that minus symbol in there. It didn't change. Now we need to be careful here. We're told that the area of the triangle is 10 centimeters greater than the area of the rectangle. So for them to be equal, we can't, and what we really need to do here is form an equation. We can't say that 24x equals 20x minus 5, because the area of the triangle is 10 centimeters squared greater than the area of the rectangle. So a couple of ways of adjusting this. We could either add 10 this side to make it equal to the area of the triangle, or we could take away 10 from this side. I don't know why, but I'm going to go with that. We should always, when we get an equation like this where there's x's on both sides, we should always do all the x's first. To get rid of the x's on one side, you've got to figure out which side there are more x's. There are more on the left, so we're going to take away the 20x from the right. So by taking away the 20x, we just get the minus 5. We have to take away 20x from the left, otherwise they're no longer equal to each other. So we get 4x minus 10 equals minus 5. We're ultimately trying to get x on its own, so let's get rid of the minus 10. So we just have 4x on its own. We have to add 10 to get rid of minus 10. Minus 5, add 10 is positive 5. And then to find x, we need to divide by 4 because we've got 4 x's. So 5 divided by 4, which is 1.25. Remember, never give your answers in proper fractions. We can give them as decimals or mixed numbers. And we're going to say, right, x is 1.25. That seems possible. Now what we can do here is come back up and check. Is x 1.25? If it is, this side, 6 times 1.25, the height of the triangle is 7.5. So the area would be 8 times 7.5, base times height, divided by 2. So I'm getting an area of 30 for the triangle. If we do the same for the rectangle, 4 times 1.25 is 5, take away 1 is 4. 5 times 4 gives us the area, which is 20. And remember, we were told that the area of the triangle was 10 more than the area of the rectangle, and that works. So we can be confident at this point that we've solved it correctly and that x is 1.25. It's a nice skill to have that, being able to check your answers to know you've done it right. Question 25 then. We need to figure out 57% of 800 kilograms, because that's what amount is paper and glass. So straight off, we can just do this on our calculator, just type in 57% times 800, or you can do 0.57 times 800 if you're happy with converting 57% to a decimal. But the percentage button will save you having to do that if you're not confident with that. So 456 kilograms of the recycled household weight was paper and glass. And then we need to share this into a 12:7 ratio. Now, when we share in a ratio, we add up the parts. So 12 add 7 is 19. So we're going to divide 456 by 19 to find out what one part is. Now we get 24. We should feel confident at that point. We didn't get a horrible decimal. If 456 divided by 19 is 24, it feels good. And then the weight of glass, so not the paper, it's the glass, that'll be 7 times 24, which is 168 kilograms. So that's the weight of the glass they recycled. Okay, question 26, just an error interval, a really learnable topic, one that we can do enough of and know exactly what we're doing. The idea behind this is if a number's rounded, it could actually be a little bit smaller or a little bit bigger. To get rounded to 12.7, it could be as small as 12.65 or as big as 12.75. Has to be between these two numbers. So we put these on the number line. Now, if it was 12.65, it would round up to 12.7. If it was 12.75, it would round up to 12.8. And that's why we've got the inequality symbol here, which is just less than 12.75. And here we got less than or equal to. And then we've got questions about a house here. So both of these houses increased by a percentage over 2 years. So this is a compound interest question. And what we need to know for that is what the decimal multipliers are for it for each percentage. So if something increases by 4%, it's 100 add 4%, 104%, which has a decimal is 1.04. So if you times something by 1.04, it will increase it by 4%. So we're going to do that to Tamsin's house. We're going to times it by 1.04. That would be for 1 year. And we would times it by 1.04 again for 2 years. Or you can times by 1.04 squared. Doesn't make too much difference here, but if it was over 20 years, it would save us having to write multiply by 1.04 20 times. That's the whole point of the powers. So 150,000 times 1.04 squared, that's going to give us the value of Tamsin's house after 2 years. And that is £162,240. Okay. And we're going to see if that ends up being more than Rachel's house. Now, Rachel's house was 160,000 at the start, so it seems likely it's going to be more, but it's increasing by a smaller percentage. Now, to increase by 1.5%, 100 add 1.5 is 101.5%. As a decimal, divide it by 100 to get it as a decimal, 1.015. So we're going to times 160,000 by 1.015 squared. And we get 164,836, which is more than 162,240. So at the end of the 2 years, whose house has greater value? Rachel. That's right, Rachel's house. Now I've come ahead and I've done some markings on these. Now what you need to do to be good at these questions is start to identify these shapes. So these two lines are straight lines. So they will be in the form of y equals mx plus c. Okay. Now, D has got a positive gradient because it's going from bottom left to top right. A has got a negative gradient because it's going the other way. They both have a y-intercept, which is what the C is. That's positive. So the way to identify these two is it's going to be between the gradients, not going to be the intercept. So if we come down here, and I already highlighted them in yellow, we've got two that are straight line graphs, these two. Now y equals x plus 3 has got a positive gradient. There's a hidden 1 in front of the x. And the second one has got a gradient of -2. So that's the one going down. That's going to be graph A. And graph D is going to be the positive gradient. Now we should start off by saying, right, I can identify a straight line graph. If you can do that, then even if we're not sure on the others, we're guessing between fewer. But what we should be looking at here is this x squared, this shape is a quadratic graph. It's an x squared. And there's none other like that. So if we come down here, which graph has got an x squared? Well, it's y equals x squared minus 4x. So that's graph B. Graph E is a cubic shape, as in x cubed. So that is y. So y is graph E. And then just by process of elimination, y equals 1 over x. That's a reciprocal graph. You'll probably feel less familiar with it. It takes this shape. This is a reciprocal graph. On my website's identifying graphs worksheet on there, all the past paper questions of this put together, kennethstafford.co.uk. If you want to try more questions like this, in the comments, if you can't find it, just say and I'll give you a link. And that is the last question on the paper, so we're done. So yeah, hopefully I've gone through that well enough for you. If not, just say in the comments if you want anything described a bit better. If any of these topics you want more questions and you can't find them on my website, just ask and I'll post the link. Hopefully that was useful for you. And I will put the solutions up on my website as well. Thank you.